Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, that is cycle geometry. We are going to have our second lesson, and in this second lesson, we are going to take the second theorem, that is theorem 2. So let's begin. After completing the very lesson today, my dear student, you'll be able to find the measure of the angles which are on the same segment of a cycle. This is what I hope you'll be able to do after completing the very lesson today. As usual, in your favorite segment of the lesson today, my dear student, I'll give you another amazing relationship between even numbers and the prime numbers. I'll explain this relationship between even and prime numbers after completing my lesson today, so be with me. My dear student, to begin the lesson, let us learn the second theorem. This second theorem will now be another vital tool while solving cycle geometry. So let us learn the second theorem. The second theorem says angles subtended by same arc, and those angles are on the same segment. So according to this very theorem, it says those two angles are always equal. Let me just use these two drawings to explain this theorem. Looking at the very first figure, let me just color the arc. Look at the arc colored red. And if I draw this very line, dotted line, I have this as one segment. This is another segment. Similarly, in the second drawing, look at the arc colored red and look at the chord that connects the ends of the arc. So this could be a one segment and this is another segment. So based on this very theorem, it says if you have two angles and those two angles are subtended by same arc, let me just consider this first drawing. Look at the arc colored red. That subtend angle X and also the same arc subtend angle Y, and look at that angle X and angle Y are on the same segment. Look at the segment. This dotted line is a code that divides your cycle into two segments. This is one segment. This is another segment. So the two angles X and Y are both subtended by same arc. And the two angles X and Y are both on the same segment. So according to this very theorem, it says those two angles must always be equal. If I go to this very drawing also, look at the arc, look at the chord. So this is one segment and this is another segment. And looking at this angle alpha and beta, alpha and beta are both subtended by this arc colored red. Look at it. Angle alpha is subtended by the arc red, and angle beta also is subtended by this same arc. And both angles alpha and beta, they are on the same segment. According to this very theorem, the angle alpha and the angle beta must always be equal. So let me just write it. Based on this very theorem, x will now be equals to y. And the angle alpha is also equals to the angle beta. And in each case, the reason you now usually write is angle on same segment. So we are going to take examples how we can make use of this very theorem as a tool in solving problems in this cycle geometry. So let us just move and take an example. Example number 1, it says find the size of the lettered angle or angles. Here in this very drawing, I have an angle lettered X and I have another angle lettered Y. Look at it. So in each case, I need to find X. I also need to find Y. So solution to this very problem. So looking at the angle X, suppose I wanted to start with the angle X. Looking at this X, the angle X is subtended by this arc. Look at the arc colored red. It is this arc that subtended this angle X. And the same arc also subtended the angle 40 degrees. Look at it. Look at it. And looking at the 40 and angle X, they are both angles on the same segment because if you draw this line, the chord, for the sake of clarity, you don't have to write it, but you can visualize that this 40 and X are on the same segment. So based on the theorem that we have just learned, the size of the two angles must be equal, which means X will now take this size of 40 degrees. So let me just write the size of X is 40 and my reason is angle on the same segment. This is just the short form of the theorem 2 that we have just learned. So I can now move ahead and find the angle Y. Look at the angle Y. Let me just start with it. The angle Y, look at it. To find angle Y, it is this arc. Look at the arc. Look at the arc that subtend angle Y. And the same arc also subtend or formed this angle 30 degrees. And look at Y and 30 degrees. They are both on the same segment, because if I draw a line from this end of this arc to this end, it will give me a chord. So that small portion would now be one segment, and the whole of this would now be another segment. So you can see Y and 30 degrees are both on the same segment, which means based on the theorem that you have just learned, Y and 30 are always equal, which means Y will now take this size 30 degrees. So let me just write it, Y equals to 30 degrees. And my reason also is angle on the same segment. So with this, I have answered this question because I have the size X as 40, I have the size Y as 30 degrees. Let me just move and take another example. Example number 2. It says, work out the size of the marked angle. So here I have angle X, I have angle T, and I have angle Y. So I need to find all those three angles. Solution to this very problem. So starting with the angle X, look at the angle X. Look at the angle X. This angle X is an angle subtended by this very arc. Look at the arc, I just colored it, right? It is this arc that formed this angle X at the circumference. And the same arc also formed the angle 30 and form angle Y. So you can see these three angles are angles subtended by the same arc. And those three angles, if you look at it critically, they are also on the same segment of this very cycle. Based on the theorem that you have just learned, these three angles, X, 30, and Y are always equal, which means X is now going to be 30 degrees, and your reason is angle on the same segment, and Y also is now going to take the same value, 30 degrees, and the same reason, angle on the same segment. Here you must write the reason all the time. So what remains is the angle T. Let me just move ahead and find the angle T. The angle T, look at the angle T. It is this arc. Look at it. It is this arc that subtended the angle T. And the same arc also, if you trace it carefully, is the one that subtended this angle 40 degrees. Look at the arc. It's the one that subtended this angle 40 degrees. And the 40 degrees and the angle T are both on the same segment of the cycle. So therefore, T and 40 will be equal based on the theorem 2 that we have just learned. So T is now going to take the size of 40 degrees, and you always write the reason. So let's just move and take one more example. Example number 3 says in the diagram below, O is the center of the cycle. Look at the center O. And the angle BAD, BAD, look at the angle BAD, 72 degrees is marked even in the drawing. And the angle CBD, CBD, look at it, 15 degrees is also marked in the drawing. The question asked here is to find the size of the angle COB. COB. This is the angle, is the angle at the center that you need to find. Solution to this very problem, what you do first, you just mark that angle that you wanted to find finally. That is the angle COB. Let me just mark it, look at it in red. It is this angle that we need to find finally. But I have this angle 72 and I have this angle 15 degrees. So let me just look at how you can now make use of these two angles given in order to find the size of this very angle. So let me just move ahead. Look at this angle 15 degrees. It's an angle subtended by this arc CD or DC. Look at it. It is this arc that subtended angle 15. And the same arc, look at it, the same arc. The same arc subtended this very angle CAD. I try to color them red so that you can visualize them clearly. This angle 15 and this angle DAC, which is also colored red. Those angles are angles subtended by same arc and they are on the same segment. So based on the theorem that we have just learned, the two angles will now be equal. So this angle would now take the size 15 degrees, that is angle CAD, will now be 15 degrees. Let me just mark it in the drawing. So if I have this angle 15 degrees, I can use it to find the size of the angle BAC. BAC will now be this very angle. Look at it. Look at it. This is angle BAC. The whole of this angle is 72. And I have this as 15. So if I subtract 15 from 72, it will leave me with this remaining angle. That is angle BAC. If I have this, then I can now connect this very angle with this very angle, because I learned theorem 1 which says angle at the center towards angle at the remaining circumference. Let me just get angle BAC. Angle BAC will simply be 72 degrees, the whole of this, minus this 15. And subtracting 15 from 72 correctly gives you answer 57 degrees, which means this angle at the remaining circumference is now going to be 57 degrees. And looking at this angle, 57 degrees is an angle subtended by this arc. Look at the arc CB. Look at the arc CB. So this CB subtended 57 at the remaining circumference, and subtended angle COB. COB is the angle we asked to find, the angle at the center. So this angle COB will now be 2 times 57. And multiplying 2 by 57 correctly gives you a result 114. So this is the size of the angle COB. Like I've said all the time, you must write the reason. So the reason of making COB to be equals to 2 times 57 is angle at the center twice angle at the remaining circumference. That is the very first theorem that we have learned in our previous lessons. So this is the size of the angle COB. With this, I have answered this question. With these 3 examples, my dear student, I have come to the end of this very lesson. I hope you find it resourceful. Let's just move straight to the next segment, that is self-evaluation segment. Welcome to the self-evaluation segment of the lesson, where you have the opportunity to measure the understanding of this very lesson today. So let's take the instruction. You have 2 questions that are there in this very test to answer, and each question will now be displayed for 1 minute. And after 1 minute, the solution of that very question will now be displayed, and that solution will be there on the screen for just 30 seconds. But you can now control the timing, that is delaying the timing for the display of the question, or delaying the time for the display of the solution to that very question, by just simply pausing the video, and you can now play the video to resume back. If you are ready, you have just 10 seconds to begin the test. Thank you for taking this the very test, my dear student. Let me just move quickly to the last segment that I will explain the interesting thing between even and the prime numbers. All even numbers can be expressed as a sum of two prime numbers. That is, you can have an even number by simply adding suitable two prime numbers. Let's just take examples. Example, we now have 18. We are to express it as sum of two prime numbers. 18 is even. We have 70 also. We are to express it as a sum of two prime numbers. We have 106 as even a number. We are also going to express it as sum of two prime numbers, starting with the very first one, 18. 18, you can have 18 by adding 13 and 5. 13 is prime, 5 is another prime number. Addition of these two primes gives you 18. If I move to the next one, 70, you can have 70 by simply adding 47 and 23. These two numbers are prime, and addition of those two numbers gives you your 70. Move to the last one, 106. You can have 106 by simply adding 130 and this 3. These two numbers are indeed prime numbers, and addition of them gives you 106. So all even numbers starting from 2, 4, 6, 8, anyone you can have it as a result of adding two prime numbers. You can try as many as you can. We see more of these things in mathematics in our subsequent lesson. Thank you for your attention.